Okay, so let's go over section 4.1, exploring the primary trig ratios of obtuse angles. So before we go over any of this stuff, I want to just review. I want to back up and I want to talk about right angle triangles. Okay, because if we're talking about trig ratios, we're talking about only work in right angle triangles. Angle triangles. Okay, so trig ratios only work if we have a 90-degree angle. So remember, trig ratios are all about the reference angle. So if I decide this angle here is my reference angle, over here is opposite, right here is adjacent, because it's next to, and across from my 90 degrees is always my hypotenuse. Okay, so remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Again, that's where that funny so choa comes from. Okay, so only works if we have a 90-degree triangle. So if we talk about the coordinate plane, okay, so I know this looks funny, but here's the coordinate plane. So let's see if I can get my highlighter out. This is the y-axis right here, and this is the x-axis right there, okay? And I'm going to get rid of that. I just want to show you y and x-axis. So what I've done here is I've just drawn two lines. Okay, so in my quadrants, this is quadrant 1 and this is quadrant 2. Doesn't matter today, but this is quadrant 3 down here and this is quadrant 4, although we're not going to be talking about those two quadrants today. So I've drawn a line in quadrant 1, and then all I've done is extend that line here down to the x-axis to make a right angle triangle. And in that right angle triangle, I've got measurements. So from here to here, I'm on the x-axis, so I can call that measurement x. I don't know how far it is, but I can call it x. And then from here to here, because I'm going up the y-axis, the distance from here to here, you would read it on the y-axis, so we could call that y. And then this we're going to call the hypotenuse. It's across from the 90-degree angle, so we're going to call it hypotenuse. And so we're going to consider this angle here, our reference angle. So the measurement from here to here, this is going to be our reference angle. And so according to this reference angle, the sine of that angle is opposite over hypotenuse. So y over h. Now that's going to be a positive number because we are in the first quadrant. And so whatever this distance y is positive because it's above the x-axis. And then the hypotenuse can be calculated using the Pythagorean theorem. X squared plus y squared equals h squared. But because we're squaring these distances, of course, they would have to be positive. So sine's positive in the first quadrant. Cosine of that angle. Cosine is adjacent over hypotenuse. Still a positive value because x will be positive and h is always positive. And then the last ratio, tan of that angle, tangent is opposite over adjacent, y over x. So that's a positive ratio, and that's a positive ratio because all of these are positive numbers in quadrant 1. Okay, so that's important to note that in quadrant 1, everything is positive. All right, so let's talk about quadrant 2. So this measurement from here to here, I'm on the x-axis, but I'm in the negative x-axis, so we're going to call it negative x. This measurement here is above the x-axis, so it's still positive y, and then this is still my hypotenuse. This will be a right angle. because I've taken this line and extended straight down. This is going to be my reference angle, same as in first quadrant, okay? So the only difference in second quadrant is the distance from here to here now will be measured in a negative because it's on the left side of my 0 here, okay? So my ratio's over here, sine of that angle. Sine is opposite over hypotenuse. Cosine of that angle. Adjacent over hypotenuse. So for the first time, I'm going to get a negative ratio because whatever this number is, like let's say this got 3 spaces to the left, this would be -3. The hypotenuse is always positive because it's calculated from this squared times this squared and then square rooted. But even if this is negative, when you square it, it will make it positive. And then tangent of that angle is opposite over adjacent, y over -x. So what's important in this second quadrant is that, oh, that's gross. I need to make that yellow. Is that cosine, hold on, I want to make that yellow. I can't read that. Cosine is negative and tangent is negative. Look at sine though. Sine is still positive. So what's important to know here is that sine is positive in quadrant 1 and 2, but in quadrant 2, cos and tan are negative. Okay, so why is that important to you? Well, we'll figure that out in a second. So let's go back to the first page now. This beginning of the page that we started with 4.1, and hopefully this will make a little sense to you now. So the first keep in mind says the value of a trig ratio for an angle, this symbol here, is related to the value of the same trig ratios for the supplement of the angle. Now, supplementary angles, those are angles that add to 180. Okay, so supplement of the angle. Okay, so here they're showing you that whatever this angle is, this will be what's left over from 180. Okay, so that's what they mean by supplement. But look at down here, they've got the 3 ratios, and they've got for any angle, the sine of that angle is equal to the sine of 180 minus that angle. So if we are talking about both ratios, and let's say we make a really simple angle of 30 degrees right here, okay? So from here to here is 30. If I go into quadrant 2 and I make this angle 30 here, in quadrant 2, because we always measure angles from quadrant 1 and the x-axis, in quadrant 2 this angle is actually 180 minus 30 or 150, because remember that the entire way makes 180. So this is saying that the sine of 30, sine of 30 is the same as the sine of 180 minus 30 or 150. So if we go to our calculator online, and I'm trying a different one here, this is metacalculator.com, and I calculate the sine of 30 degrees. Up here it's 0.499999, or basically 0.5. So I can say that the sine of 30 is 0.5. And then if I go back and I say, yeah, but what's the sine of 150? And I change that to 150, look it up here. It still says 0.5. And that's because it doesn't matter what quadrant you're in. It doesn't matter what quadrant you're in. Hold on, you're in the wrong thing. Doesn't matter what quadrant you're in, sine is the same thing. So in quadrant 1, sine is opposite over adjacent, y over h. In quadrant 2, sine is y over h, opposite over adjacent. So in both quadrants, sine is positive. So that's sort of the point of this lesson. All right, let's go though about cosine. So let's talk about the same angle, that 30-degree angle. So we're going to say in quadrant 1, it's 30. In quadrant 2, if this is 30, I'm really talking about 150 because we don't measure from here. We always have to measure from quadrant 1 in the x-axis. So here to here's 30. The supplementary angle, that's 150. So if I go, hey, what's the cos of 30? Go to my calculator. If I say cos, let's clear, cos of 30, I get 0.866. And so if I ask it what the cos of 150 is, now remember what I told you. In the second quadrant, cos is negative. Okay, cos is not the same in both quadrants. In quadrant 2, cos is negative. So the cos of 30 and the cos of 50 should not equal each other. So I'll ask the graphing this calculator, what's the cos of 150? And notice it says negative 0.866. So something's going on. It's negative 0.866. Ignore this little dot, sorry. So here it says that in order to make them equal each other, I have to take the one in quadrant 2 and I gotta multiply it by -1. So the only way that I can say that the cos of 30 is the same as the cos of 50, I need to stick a negative in front of it. So I can say cos 30 equals negative cos 150. And so on the calculator, if I say negative, I don't know where the negative symbol is. I'd have to multiply it. Is that going to work? Negative, let's see. Cos 150. There's that positive right there. There's the positive 0.866. Okay, so remember, that's because in quadrant 1, cos is positive, but in quadrant 2, cos is negative. Okay, same good thing's going to go on for tan. Look at tangent. Tangent in quadrant 1 is positive. Tangent in quadrant 2 is negative. So it's the same identity here. In order for the tan to be the same, you're going to have to multiply it by -1. So if I ask my calculator, what's the tan of 30? Clear it. Tangent. Tan. Couldn't find it. Tangent of 30, it's 0.577. The tan of the supplementary will be, what do you think? There it is, that negative 0.577. So the only way that I'm going to make it equal is if I say the tan of 30 has to equal negative tan 150. That's the only way to make them equal, because in quadrant 1, it's positive, but in quadrant 2, it's negative. Okay? So we are talking about obtuse angles, and that's why it's happening. Obtuse meaning more than 90 degrees. So there's only 2 examples in your notes. And the first one says determine the measure of 2 angles between 0 and 180. And here's a big old hint. That have each sine ratio and round each answer to the nearest degree. Okay, so the ratio. So we already have opposite over hypotenuse. If they say this is the sine ratio, we've divided the opposite by the hypotenuse and got 0.34. So the way that you get the angle is you ask your calculator, hey, I have the ratio, what angle gives me that? So make sure that you use this inverse. That's the way that you ask your calculator, right here. What's the angle? calculator. And that's this button here. Okay, I know it comes up as A, arc sine, but sine -1 of 0.34. And angles are always rounded to the nearest whole number, so 19.87, we're going to call that 20 degrees. Now, we know that sine is positive in the first quadrant and the second quadrant. 0.34 doesn't tell you if it's in the first quadrant or second quadrant because it's positive. It could be either. So because it's sine and because sine can be positive in both quadrants, you have to do the angle in quadrant 2. Okay? So because this is less than 90, this is the quadrant 1 angle. The quadrant 2 angle will be 180 minus 20, or of course, it will be 160. So the sine of 20 is the exact same as the sine of 160. Sine of 20, there it is, 0.34, is exactly the same as the sine of 160, 0.34. So when you're talking about a sine angle, you have to remember to do both quadrants. Both quadrants for sine. Okay, so this one was 0.34. They'd already done the division for you. In the second example, they're saying that the ratio was 4/7. So if we had a right angle triangle, oh boy, I'm drawing. We had a right angle triangle, and this was the reference angle. Sine is opposite over hypotenuse. That's what they're saying is happening, okay? But remember, it could be in both quadrants. So opposite over hypotenuse, or it could be in this quadrant, opposite over hypotenuse. So we have to ask our calculator what angle comes from a ratio of 4/7. And the way you ask your calculator about angles is you inverse. So you simply go inverse sine and then go 4 divided by 7. 34.84. So we're going to say 35 degrees. But because it's sine and it can be positive in quadrant 1 or quadrant 2, so if I know it's 35, that means this is 35, or it means this is 35. But to get the quadrant 2 angle, I'd have to 180 minus 35, which is 145 degrees. All right, so please ask me if you have any questions as you're doing your practice.